Alright guys, today's goal, the learner will be able to graph sine and cosine sinusoids. These are always based on radians, guys, just to let you know. State the sign that is positive or negative of each quadrant. So quadrant 1, all are positive, so positive. Quadrant 2, sine is positive. Negative, negative. Cotangent. A smart trig, so quadrant 3, so 1, negative, positive, negative. Give the radian measure. Remember, you multiply by pi over 180. So 5 pi over 6 negative 3 pi over 4. Find the transformation. It's a vertical stretch by a factor of 2. Okay. There we go. There, what you learned about the basic waves revisited, sinusoids and transformations. Same transformations as before, guys. Modeling periodic behavior with sinusoids, and why sine and cosine gain added significance when used to model waves and periodic behavior. A function is a sinusoid if it can be written as the form f of x equals a times the sine of bx plus c plus d. A times the sine of the quantity bx plus c, and then plus d. When neither a or b is 0. Same thing for cosine. The amplitude. See, there's going to be another page that helps us, but the amplitude is the absolute value of a. The period equals 2 pi divided by the absolute value of b. Period is how long does it take for it to repeat itself. Okay? The frequency, absolute value of b divided by 2 pi. It's the inverse, or it's the reciprocal of the period. The frequency of a sinusoid, graphically the frequency is the number of complete cycles the wave completes in a unit interval. Okay? Here's, see, a times b x minus h plus k. We've seen this. Amplitude, period, frequency. Make sure we're copying these down. Okay? When compared to the graphs of y equals a times sine bx and y equals a times respectively, they also have the following characteristics: a phase shift of h and a vertical translation of k. Alright. Determine the maximum value m and the minimum value m. So, the amplitude, to get a, if you can't get, if you're not given the equation to get the amplitude, you do max minus the min divided by 2. And to get c, or in the other form k, max plus min divided by 2. B equals 2 pi divided by the period, but you could get that from period equals 2 pi divided by b. Okay? So, the way to pick which one you're going to use, if possible. If it starts at a max or a min, you use cosine. If it starts at a 0, you use sine. Okay? So let's move on. Find the period of y equals x divided by sine of x over 2 and use language of transformation to describe how it relates to that. So I would rewrite this So I know that b is 1/2. So I get that the period equals 2 pi divided by b. Well, multiply by the reciprocal. So the period is 4 pi. And that would be a horizontal stretch by a factor of 2, I think. Let's see. Could be a compression. Stretch, yep, by a factor of 2, because remember it's the opposite. Okay. Here's your basic sine and cosine. Now, a couple pages ago when I was talking about positive a, negative a cosine, remember how I said if it starts with a max? See how cosine at 0 is the maximum value? If it's a negative, it means it's reflected over the x-axis, and it would start down here at the negative value. And sine, if it's positive, it starts at 0 and goes up, and if it was negative, it would start at 0 and go down. Okay? Construct a sinusoid with period of pi over 3 and amplitude of 4 that goes through 2, 0. Okay. So the amplitude of 4, that means it increases by going up 4 and down 4. So I know A is 4, and I know period is pi over 3, so B equals 2 pi divided by pi over 3 multiplied by 3 over pi. Those cancel. You get 6. Okay? Now, this is where we need to think about the unit circle. The easy points to graph are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. The period of the unit circle is 2 pi. Well, cut it into fourths. So what's our period here? Pi over 3. So to get our scale, I multiply that by 1/4. I would make it pi over 12. So I get pi over 12 pi over 6, because 2 pi over 12, 3 pi over 12 would be pi over 4, pi over 3, and then do the negatives. Okay, now this point tells us it's starting at a 0, so we should be using the sine function. Except instead of 0, 0, it's 2, 0, so that means h equals 2. So we get y equals 4 times the sine of 6 times x minus 2. And then here's the thing. Well, we didn't have to graph it this time, but that's how we're going to set our scales to be able to graph these. So there's our equation. And actually, you probably should go 4 sine of 6x minus 12. Okay? There we go. So it says find B is plus or minus 6? Yeah, because we were absolute value, but we don't know if it's positive or negative, so you just choose the positive values, okay? All right, so remember, the amplitude equals max minus the min divided by 2, so you get 2. But why is it negative 2? Because it says the sinusoid rises from a minimum value. It's starting at the minimum. That means it's negative. Okay? And then B equals, or well, not B yet. C equals max plus the min divided by 2. So it's 4. So we need B. Well, the period is 12 because if it goes from the minimum to the maximum at 6, to get back down to the minimum and start heading up again, it would take another 6. Okay? And that equals 2 pi over B. So B equals pi over 6. Okay? So we have A, B, and C, or K, however you want to think about it. And there was no horizontal shift because it was starting at x equals 0. So you have y equals negative 2 cosine pi over 6 times x plus 4. Okay? This cosine looks ugly. There we go. Let's try one more. It says construct a sinusoid f of x that rises from a minimum value of y equals 1 at x equals 0 to a maximum value of y equals 5 at x equals 4. Okay, so A. Max minus min divided by 2 is 2. And it's negative 2 again. Why? Because it starts at a minimum. C. Max plus min divided by 2. So it's 3. Now, to go from the minimum to the maximum, it takes 4. So our period is 8. Which equals 2 pi divided by B. So B equals pi over 4. And the 0 minimum, well, we already have that. There's no horizontal shift, so you get y equals negative 2 cosine pi over 4 times x plus 3. We'll be doing some examples in class tomorrow. See you guys then.